morning everyone. Welcome to the first video which is on kinematics and mechanics. This will be published tomorrow evening by 5 p.m. That is on 9th September 2024. Okay. So currently this video is for 15 minutes, but I'm breaking this video into two parts, one for 7 minutes, other one for 8 minutes. Okay, as I told you, my laptop gets heated up, or maybe the video recording software doesn't hold for more than 10 minutes. I'm going to break this one into two parts. Okay, so towards it, first question, define linear momentum. What is linear momentum? Linear momentum is defined by momentum P is equal to mass multiplied by velocity. This is sufficient, mass into velocity. This is your linear momentum. Next, state in terms of linear momentum the Newton's second law of motion. What is Newton's second law of motion in terms of momentum? That's what you need to mention. So it tells you that F is equal to rate of change of momentum. So this is what you need to write, and at the same time you should write this should be equal to Pf minus Pi divided by delta T, where Pf is the final momentum and Pi is the initial momentum. Okay, you definitely need to write so much because you are stating the law, but at the same time in terms of this, so it is this much big, you need to write this, right? And then next one, so show using your answer to be how the impulse of a force F is related to the change in momentum delta P as it produces. Okay, so you need to relate the impulse force F and change in momentum to the impulse. Okay, impulse of a force. So we know that from the previous discussion, we have written F is equal to Pf minus Pi divided by delta T, which should be equal to delta P divided by delta T. Okay, so thus what you should say, right, is that the impulse is equal to F times delta T, which should be equal to delta P, change in momentum. Okay, you should stop here. Then next question, a railway truck on a level straight track is initially at rest. The truck is given a quick horizontal push by an engine, so that it rolls now along the track. Push from engine is given, velocity is given over here. Okay, the engine is in contact with the truck for a time of 0.54. Now what does it say? There is a railway truck over here which is initially at rest. Straight track is initially at rest, so rest, which means rest here. Truck is given a quick horizontal push by an engine. Let me write the engine here. This is the engine, and which now rolls along the track. Okay, so this was moving actually and hit it over here. There's a collision. That's what it means. There was a collision. The engine is in contact with the truck for time is equal to 0.54 seconds. So this is in contact for 0.54 seconds. And the initial speed of the truck was 4.3 meter per second. The mass of the truck is 2.2. So this is 2.2 into 10 to the power of 3 kgs. Due to the force of the magnitude F is exerted by the engine of the truck, the sketch shows how the force F varies with time. What is this force given by? Force is nothing but, initially you see the force is 0, which means what? The engine was not in contact with the truck. The moment the engine got in contact with the truck, then what happens? The force started to increase, because as it comes and collides over here, it keeps on increasing, and thus the object starts moving, right? It went to a maximum 1, and after that the force started reducing and force became 0. When the force becomes 0, what does it mean? That means the truck and the engine are no more in contact with each other, right? That's what it tells you. It has taken a time t. So can we identify where is this time t? Time t is from here. Okay, so time t here, this value is 0.54 seconds. The rest of the nothing is known over here. Okay, then sketch the magnitude of the maximum force F exerted by the engine on the truck. What is the maximum force F maximum? How do we do it? Now you see, if I take the area of this graph, what does the area gives you? Area will give you F into delta T, right? F into delta T. What does it give you? This is nothing but your impulse. What is your impulse over here? Impulse is nothing but m delta v. We already seen change in momentum, right? So m delta v. So therefore, now what we do is, let us find the area here. So I do not know what is F max over here. F max half into altitude multiplied by time taken. Time taken is how much? 0.54 seconds should be equal to mass m into v. M into what? Delta v over here. Now what is m here? M is 2.2 into 10 cube, right? So let us substitute this value, 2.2 into 10 cube multiplied by v, delta v. What is delta v here? Initially, what was the velocity? 0 of the truck. What is the final velocity? 4.3. So your answer here should be 4.3 minus 0, right? So therefore, Fmax is equal to 2.2 into 10 cube into 4.3 divided by whatever is here. Now there's a 2 also here. Cross multiply, this becomes 2 over here, and this is divided by 0.54. Let us find out what is this value. Let me go to CALC calculator, and thus now I am arriving at this value. This value would be 2 star 2.2 star 4.3 divided by 0.54. So which comes out to be around 35.03. Okay, which should be equal to 35.03 into 10 cube. Unit is force, Newton. So this is nearly equal to 35 kilonewton. Okay, so with this we have come to an end to 4 plus here 3, 7 marks within 6 minutes. Okay, let us continue with the next problem, next part, the same part of the problem in the next video. Thank you.